In this presentation, we are going to look at a few mathematical matters relating to Julia. Prime numbers, factors, complex numbers, and mathematical constants. So first off, let's look at prime numbers. Essentially, the primes command is used to generate all prime numbers less than n. Let's see how that works. So this is Julia Studio, and so let's say all prime numbers less than 10. Let's give it a sec there. 2, 3, 5, and 7. All prime numbers less than 20. There we have it there. 2, 3, 5, 7, and so on. So that is the primes function. It just generates the prime numbers. Now it's quite handy if you're for certain operations. I use it a lot for in MATLAB. I use it a lot for coming up with exam questions. So that is the primes function. Straightforward enough. Now, to determine whether or not an integer is a prime number, we use the isPrime command. For example, isPrime 7. Now let's go back to Julia Studio there. So isPrime 7. Is that a prime number? Yes, it is. Isprime 8. Nope. Let's do something awkward. Pi. No method. It doesn't work for mathematical constants. How about 8.5? Nope. Doesn't work for floats either. Essentially, it has to work for integers. And so it's a sort of very straightforward command. It only works for integers. It is not like other commands, for example, isLtype. Okay. Now, that's prime numbers done. So let's move on to the next thing. So factors. To compute the prime factors of a number, we use the factors command, or factor. The output indicates the prime factors and the number of times that each factor is used in the multiplication of the inputted number. So a single input means that the inputted number is a prime number. Okay. So factor, let's clear the screen here, first off. I should go F4. Why don't I just use F4? So the factor of, let's say, 8. So that is the factor. The prime factor is 2, and it is used in the multiplication 3 times. That is to say, 2 times 2 times 2. If we were to do for 16, if we were to do it for 16, or let's say 18. There we have 2 times 2, which is just to be used once, and 3, which is to be used twice. So that's to sort of say 2 star 3 star 3. Okay. The next one is let's do it for a prime number here. So factor of 11. So it only gets used. It's a single prime number. It only gets used once, so it is 11. Okay. Okay, that's prime numbers and the factors. So I've probably overdone that there a bit. Okay, moving on to the next thing here: complex numbers. To build complex numbers, you can use the complex command specifying the real and imaginary components. So, for example, if we were to construct the number 7 plus 2i, we type in something like this: complex 7 and 2. Okay, and we get an output like that. 7 plus 2im. Let's just see, can we actually write something like that in directly? So we're going to call this A, 7 plus 2im. Does that work? Yes, it does. Works fine. So type of A, complex number. So you actually do not really need to use that command there, complex. You can actually write the number in specifically, specifying that the imaginary part with an im. Okay, so you can use both. There's a couple of commands that are related to complex numbers. They're straightforward enough. For example, real of A is the real component of A. You can have the imaginary component, which is 2. You can have the complex conjugate of A, which is 7 minus 2im. You can also have the absolute value, which is 7.28. Now so far those are the only complex functions related to complex numbers I can find. So there's a couple other ones, like if you're familiar with complex numbers, you might the phase angle theta. There's nothing really there yet. Maybe I'm wrong, but I haven't found anything. Okay, so that's complex numbers. And finally, mathematical constants. So there's a couple of mathematical constants recognized by Julia: pi, Euler's coefficient, Euler's gamma, and the golden ratio. So let's have a look at those. So pi, there we go, 3.1415. Okay, you might notice that it's given with a Greek letter there, pi. Euler's number, or also EU, and the golden Euler's gamma. There we have it there. That's gamma there. And finally, the golden ratio number, sometimes known as phi. So that is it there, 1.618. All right, that is the mathematical coefficients. That's everything there. Okay,